Hey there, I'm diving into some fascinating new research on brain plasticity after nerve reconstruction surgery. Ever wondered how our brains adapt following a brachial plexus injury? Recent studies using rat models have shed some light on this. Researchers explore three surgical strategies: grafted nerve repair, end-to-end nerve transfer, and end-to-side nerve transfer. By comparing these methods, they aimed to understand how each approach reshapes brain networks. Advanced brain imaging was the key to this research. They zoomed in on two critical networks, the sensorimotor and interoceptive systems. So what did they find? Well, grafted nerve repair significantly boosted sensorimotor network connectivity, which is crucial for sensory recovery. Imagine regaining the ability to feel and touch. That's a big deal. End-to-end nerve transfer, on the other hand, provided solid results but didn't quite match up to the other methods in terms of comprehensive recovery. Still, it played an important role in restoring some functions. Now here's where it gets really interesting: end-to-side nerve transfer. This method not only restored motor control, but also engaged brain areas linked to cognition and emotion. It's like hitting the jackpot in terms of overall brain plasticity. These findings highlight the unique ways different surgeries influence our brain's adaptability. Understanding these responses allows us to tailor our approaches, optimize recovery, and ultimately improve lives after nerve injuries. So, what does this mean for us? By leveraging these insights, medical professionals can enhance healing processes and provide better outcomes for patients. It's a step forward in our quest to unlock the full potential of brain plasticity. Thanks for tuning in, and stay curious, my friends.